Got it. Got it.
Okay. So guys, subnetting, we are starting with this now, and these points we will try to cover up. First, we will brush up our binary concepts. Next, we will do some scenarios from network point of view, some scenarios from host point of view. Then after, we will go to the VLSM part. Okay, so this is all like acronyms as of now. Once we move into the topic details, we will get the clarity on this. Okay. So before starting, I'll just give you one short story that will make this concept little easy to understand. So suppose there is one scientist named Rico, and he invented a kind of bricks. Okay, special bricks. That these bricks are like a undestructible bricks, but he's not good in business, so he employed one guy, named Bob, and Bob, with his hard work, assembled few customers. This first customer is very happy. He need 210 bricks, and he's the first one to get served. Okay. Second customer is little anxious, and the third one is very angry. He just need 15 bricks, but still he has to wait to get these two customers' requirement fulfilled. Then that requirement of this customer will be fulfilled, so he's like a little angry to get this done. And see the position of Bob. He's like a sweating out because of hard work he has to do. So what he suggested to Rico, that we, before delivering it these bricks individually one by one, why not we will create a stack beforehand. Okay. So what he did, he come up with a stack, means pre-made stacks, and the stacks are like this: 128, 64, 32, 16, 8, 4, 2, and 1. Okay, so the first customers need 210 bricks. So guys, can we give the first stack in that? And if we give the first stack, that we have to subtract from here, right? So what will be the remainder for that then? This 10 minus 8 will be
True.
2, right? And this 20 minus 12, because 1 we have to give to the 0. So 20 minus 12 will be uh, 8, correct? This 82 will be the remainder. Can we give the second stack to the customer? Right? We can give that second
No.
stack because 82 is the requirement. So second stack will also be there in that,
Mhm.
right? So if you give second stack, again 64 will be subtracted. So 12 minus 4 will be 8, right? And 7 minus 6 will be 18. Okay. So
Okay.
guys, can we give the third stack here? If we give third stack, that Rico will be in
Yes.
loss. So we cannot give third stack because 18 is the bricks, reminder bricks that we have to give. So we cannot give 32 stack. Okay. But we can give 16 stack.
Mm.
Correct. And if you give 16 stack, the remainder will be 2 only. So
Right.
8 will be 0, 4 will be 0, 2 will be 1, and one stack will be 0. Okay, so it's like a for binary for the 210. Okay, on the similar line, we can do a calculation for the next customer, that is 120. Okay, so if customer requires 120, can we give a stack of 128? 8 more bricks will go, right? We cannot
Right.
give the first stack, so we have to skip that one. But we can give 64 stack. If you subtract that 64, the remainder will be 56, correct?
Right.
And 56 minus
30.
32, next stack is 32. So 32 also we can give. Okay, so we'll give 32. Okay, and if you subtract 32, the remainder will be 24, correct? And 24 minus 16 will, the remainder will be 8. Okay, so here we can give it like 16,
One,
8,
one, one.
and rest all
Zero.
zeros. So this is the like a simplest form of binary we can understand from this. Okay, and the last customer required just 15 bricks. So how we can calculate? 8 plus 4 plus 2 plus 1. 1 plus 2, 3. 3 plus 4, 7. 7 plus 8, 15. Okay. So 1 plus 1 plus 1 plus 1. And rest all are 0. Any doubt in understanding this story along with this binary?
No.
Simple it is, right?
Simple.
Just addition or subtraction, that's it. Okay, now we will try this is like a warm up exercise for you guys. I'm pausing the video for next 5 minutes, 2 to 5 minutes. Just warm up yourself for the binary calculation. So do a calculation for 180 and do a calculation for 41 yourself, and then we will do a reverse calculation from binary to a decimal. Okay. Okay, so this scenario says that we require three three LAN networks and two WAN networks. To total five subnets, we have to come up with this one network, one IP network. Okay,
Right.
so three within a three steps we can reach to the answer. Okay, so first step is find number of network and convert to binary. So how many subnets we require? Five.
5.
That's what I have written here, 5. Then we will convert it into binary. So if you use that scale, so 4 plus 1 is 5. So 1 0 1, 1 0 1 means the first has a weightage of 1, the second has a weightage of 2, third has a weightage of 4. So 4 plus 1 is 5, right? So to represent 101, we require 3 bits. Any
Right.
doubt in this?
No.
It's simple, right? Reserve bits in subnet mask and find a block size. So this is a class C network. 200.1.1.0 is a class C network. So subnet mask for that is 22255.0. And if you convert it into binary, it goes like this. 255 means 8 times 1, 8 times 1, and this is again 8 times 1. And this last 0 means 8 times 0. These are the decimal values and these are the binary values. Okay, so 24 1 we have in a normal subnet mask. Okay, without subnetting. Okay, 24 network bits are there, but with 24 network bits we cannot accommodate this additional 5 network or additional 5 subnets, so we have to increase number of network bits. So how many number of network bits we will increase? That we have did
3.
in the calculation of the first step, that 3 additional bits we require. So that I have put it here, 111, and then rest of the bits will be as it is, means those bits will be zeros. So slash 27. Okay. So it will be represented like this: 255, 255, 224. Okay, and the block size will be 32. How the block size will be 32? Because this last one represent your block size. So what is the weightage of this last one which I marked as a red? So first one has a weightage of 128, second one has a weightage of 64, and third one has a weightage of 32. So I'll consider this last one as a block size. That's why here I written it as a block size of 32. This block size I'll accommodate in the ranges. So 200.1.1.0, next range will start with 32, next range will start with 64, fourth range will start with 96, fifth range will start with 128, and sixth range will start with 160. If sixth is 160, then fifth will end up one number less than that. So before 160 we have 159, so that's why fifth range end up on 159. Whereas fourth range end up on 127 because fifth range is starting with 128. Likewise, we are arranging these ranges. Okay,
Can you please explain ranges again?
I'll explain. See, the first range is this one, 200.1.1.0. Clear?
Right, right.
Next range we will calculate with the help of block size.
Mm-hmm.
Okay, so here we have calculated the block size is 32 in the second step, correct? So that I'll use in the range calculation of the third step.
Just hold a second. How we calculate the block size 32?
See, this last one represent your block size.
Okay.
Okay, so last one weightage has 32 here.
Mm-hmm.
Okay, that's why I'm taking block size as 32. So
Right.
0, 32, 64. Okay,
Okay.
that's how the
Clear.
range will progress up to 160. And from reverse calculation, like 160 here, so 159 here, and if it's 32 here, 31 here. Okay, so this way we can calculate the ranges very easily
Okay.
without involving that 2 raised to n calculation. There is another method which includes a mathematical formula of 2 raised to n minus 1, something like that. But we don't have to care about that formula. If you implement the steps, it's very easy to do the calculations. Okay. Uh, One question: can we use these ranges straight away? Directly, we cannot use these ranges on the devices. We have to skip few addresses from these ranges. Which addresses we cannot use for our ranges? Means like a for IP address assignment. The first one and the last one. Okay, why we can't use the first IP address and why we can't use the last IP address?
First one is network ID, last one is broadcast ID.
Correct, so that's why we have to skip those. So 0 is the network ID and 31 is the broadcast ID. If you take the second range, 32 is the network ID and 63 is the broadcast ID. Okay, so first and last we have to skip, and within this range we have usable IP address. That means 1 to 30 is the usable IP address range in the first range, and 33 to 62 is the usable IP address in the second range. 65 to 94 is the usable IP address in the third range. Likewise. Clear with this? Any doubt in that?
No, that's clear.
Okay, and I forgot to mention this, like if you convert this in a decimal format, this subnet mask, it will be 224. How it will be 224? 128 plus 64 plus 32. If you add them up, it will be 224, and in a slash notation it will be slash 27. Now one more question is there, like 200.1.1.0 is the network, and we need to divide it into 50 subnets. Okay, so how we can do the calculation for this? It's again very simple. uh, Same trick we will use for this calculation also. So we require 50 subnets or 50 networks, okay, out of one network. So how many bits will be required? Okay, as customer require 50 bricks, you can apply that same story. So we cannot give 128 and we cannot give 64 as well, but we can give 32 stack, right? So first subtraction will go from 32, then that point onward few bits will be turned on, few bits will be turned off, but I'm not after the binary actually. I want number of bits that I have to accommodate in the subnet mask. So if you calculate from 32 onward, 1 2 3 4 5 and 6 bits will be required to represent 50 additional subnets. Okay, that I am going to adjust here in the second step. Okay, so additional 6 network bits I have added here, and rest of the bits will be host bit. Okay, if you calculate this in a decimal format, it will be 22255.252. Okay, and this last one represent your block size. So what is the weightage of this last one? So here we have 1, here we have 2, and here we have 4. So that block size is 4. Okay, clear so far? Any doubt, guys? Next we have ranges calculation, and ranges calculation will be like this: 0, 4, 8. Okay, because block size is 4, 12, 16, 20, like this. Okay, and this will end up on 0 to 3, 4 to 7, 8 to 11, right? So how many usable IP addresses we have in these ranges?
4,
Two.
How many usable IP addresses we have in this?
4, 2.
4 is the
Two.
block size, right? But whenever we have a block size, that total block size you cannot use as it is. You have to skip the first IP address and you have to skip the last IP address. So 2 will be subtracted from that, and we will have a usable IP address only 2. So in the first range we have a usable IP address 1 and 2. In the second range we have a usable IP address 5 and 6. In the third range we have a usable IP address 9 and 10, like this. Clear with this?
Yes.
These two calculation we did from the network point of view. Now we'll do one more calculation from the host point of view. Okay, so same scenario is there, but the question has been little tweaked here. Class C address 200.1.1.0 and would like to address this network with 30 hosts in each subnet. So every subnet which we are going to create here should accommodate 30 hosts. Okay, so the calculation will be like this: find number of hosts and convert to binary. So how many hosts we have? 30 hosts. So how many bits will be required to represent this 30 hosts? So we cannot give 128 stack, we cannot give 64 stack, we cannot give 32 stack, but we can give 16 stack. So some of the bits will be on and some of the bits will be off according to binary, but we don't care about the binary. If you want to do a binary, that is also very simple. 16 plus 4 is 20 and 8 plus 2 is 10. So 1, 1, 1, 1 and then 0. Okay, but how many bits are required for that? 5 bits. Clear with this? Only 5 bits are required. And a second step, we will adjust these additional 5 bits in our subnet mask, but not as a this network bits, but as a host bit. And you know, this network bits are 1 bits, consecutive 1 bits, and this host bits are consecutive 0 bits. So here we have consecutive 50 bits that are reserved for this host portion, and rest of the bits will be network bits. And that point onward we have the same calculation as we did in the first example. Okay, the ranges are same, 0 to 31, but every subnet is accommodating 30 host only. The block size is 32, but after subtracting the first IP address and the last IP address, I mean network IP address and the broadcast IP address, we will get the usable IP address range of 30 hosts each. In every subnet will get 30 hosts only. Clear with this? These are also this is also a very simple scenario to understand. I hope all of you are understood these questions.
Yes.
Okay, but these scenarios are not very helpful in real world environment. These are called as FLSM, fixed length subnet mask, whereas in industry we use VLSM, variable length subnet mask. What's the difference between FLSM and VLSM? The subnet mask. Subnet mask in FLSM is fixed, whereas in variable length subnet mask, the different subnet masks we can utilize. Because see, a requirement of every department will not be same. Suppose Bangalore is head office, so that require more number of hosts, whereas Mumbai is mid-size branch, so we require few number of hosts there. Chennai is a small branch, so we require very small number of hosts there. But on the WAN we just require two hosts, one at this Bangalore point and one at the Mumbai point. Same on the WAN link between Bangalore and Chennai, we just require 2 hosts. But if you give plain subnet mask on all subnets, so it's like a 30 host here. Suppose the requirement is 60, so we are running out of IP addresses here. In Mumbai, suppose we require 30 hosts, so that will be perfect. But in Chennai, suppose we just require 10 hosts, but we are giving 30 host IP address range. So it will be like a wastage of IP address on Chennai end. And here also, and Mumbai and Bangalore WAN, we are using block size of 32, but only two are required. So after subtraction of broadcast and network ID, we have a usable IP address range of 30. If you subtract two from them, as we have utilized one here and one here, rest of the 28 IP address will go on west. Same is the wastage on the Bangalore to Chennai WAN link as well. So this is not a efficient usage of the IP addresses. So what we need in that case, we have to go for the VLSM solution. So let's take this scenario and we'll work out this scenario. We'll first take these steps also, and we'll just manipulate these things. So we have to start with the highest number of hosts. Okay. So what is the highest number of hosts in our calculation? It's Bangalore, right? 60 hosts we require here. So we will do a calculation for Bangalore first. Then we'll do the calculation for rest of the networks. Okay, let me write it here. So number of hosts we have here 60. Okay. And how many bits will be required to represent 60? That bricks 60 bricks are required. So we can give a stack of 32, right?
Right.
So how many bits will be required there? 32 onward means 2 bits we have to skip, and these are the 6 bits, right? 32, 16, 8, 4, 2, 1. Okay. Exact number if you want, that will be like this: 32 plus 8 will be 40, and 16 plus 4 will be 20. So 20 plus 40 will be 60. Okay. So double one, and then 00. Okay. So 6 bits will be required here. Okay. Now these 6 bits we have to adjust in this portion. Okay. So these 6 bits are the host point of view. So 6 0 bits. Okay. And 2 network bits. Let me write it like this. So 2 network bits and rest of the host bits. 6 0 bits means 6 host bits. Okay. So what will be the decimal for that then? What will be the decimal subnet mask for this? 1 plus 1. This what is the one weightage? This first one weightage, and what is the second one weightage? First one weightage is what? 128. Second one weightage is what? 64. If you add them up, what will be the value? Correct. So the value here will be 192. Let me write it here. 192. Okay. And this the C slash notation will also be different. Here it will be slash 26. Okay. Not slash 27. What will be the block size for this, Madhu? What will be the block size? This one and this one. So last one weightage is what? 64, correct? So block size we can consider 64. Block size or increment size, either word's correct. So we are starting with 0. Okay, the next range will be 64. That's why the first range will end up on 63. And as we require just one subnet or one network for that, so we'll just stop here and we will use this subnet on the Bangalore side, 200.1.1.0 to 63 with the subnet mask of 26. Clear with this? I hope there should not be a doubt on this. If you have, you can ask me. Let's remove this portion. So 27, this is not 27. Okay. Next calculation in line we have Mumbai. Okay, that's 30 host only. So let's change these values. Guys, how many bits, how many hosts we require? 30 hosts. So how many bits will be required for this? First subtraction will go from where? If customer require 30 bricks, we can give a stack of 16, correct?
Right.
So 1, 2, 3, 4, and 5. 5 bits will be required for us to represent this. Yes. So let me write it here. So first 111 0 and then 4 times 0. So it's 50 bits, that is host bits. Okay. And slash notation will be slash 27. And here the decimal value for subnet mask. What should be the decimal value for subnet mask here? This one is 128, this one is 64, and this third one is 32. If you add them up, the total value will be 224, correct? So we'll write 224 here. And the block size will be the last one weightage. So last one weightage, this one weightage is 32. So that I'll write it here. Okay, correct. Let me write it on the ranges like this. So 0, next range will be 32, next range will be 64. Okay. This and next to that we will have a range of 96. Okay, we are not doubling the value. Instead of that, we are just adding 32, 32, 32 like this. Okay, so first range will end up on 31, second range will end up on 60, 63, third range will end up on 95. Okay, and I'm going to skip these two ranges, but I'll use this third range. Okay, here in Mumbai like this, 200.1.1.64 to 95, and the subnet mask will be 27. Guys, why I skipped the first two ranges? I cannot use 0 to 31 and 32 to 63. Is there any reason you figured out why we are skipping these first two ranges? Correct. We already taken that in the Bangalore site. So that's why we have to skip. We cannot repeat the IP address. Okay. So definitely we have to skip that. Okay. Correct. So I guess others are also clear with this. Okay. If you have doubts, you can ask. Next, we have a Chennai location with 10 hosts. Let me arrange these things. Okay. So here we have 10 hosts. So the bit size will be
4.
correct because first subtraction will go through 8 and bit size will be 4. Correct. And that we will adjust here. So first 4 bits will be 1 and next 4 bits will be 0. Only 4 0 bits are required or 4 host bits are required. And if you write it in a slash notation, it will be 28. If I write it in a decimal format, what will be the value here on a decimal format?
128 plus 64 plus 32 plus 16.
So total,
240.
correct, 240. So let's write that 240 value here, 240. And what will be the block size then? The weightage of this last one, that should be
16.
16, correct. So let's write that 16 here. And I'm going to jump directly to the 96 because intermediate ranges I cannot use or initial ranges I cannot use. So I'm just writing 96 here. Next range will be 112. Okay. So the first range will end up on 111. Okay. So that I'll write on a Chennai location 200.1.1.96
slash 28.
up to 111 with slash 28. Okay. So I'm writing it. These are the theoretical values and uh, because I'm the when we do actual implementation on the router, we have to skip the first and last value. 0 to 63 is not usable directly. 1 to 62 is usable IP address range. Okay, but for the sake of simplicity, I'm writing it from start to end. Is this done or we have something to finish it up? Is there anything remaining in this calculation? What is remaining, Shijesh? Correct. WAN is still not addressed. So we have to address this Mumbai to Bangalore WAN and Bangalore to Chennai WAN. So what's the requirement of these WAN that we have to write here? How many bits are required on WAN subnets? Let me adjust these things. Only two IP address, correct. So I'll write two here on the host portion. Okay, and 2 bits will be required here. So all rest of the bits will be network bits and only 2 bits are the host bits. So the slash notation will be 30. Okay. And what will be the decimal format subnet mask? Correct. 252. So I'll write 252 here. Okay. And the block size will be, what will be the block size in this case? Weightage of this last one. So what is the weightage of this last one? So 4 it is, right? Correct. So let's adjust these calculations here. So instead of starting with 0, I'll directly go to 112 because last is 111. So I'll jump to 112. 116 is the next range and 120 is the next range. Okay. So 112 will end up on 115 and 116 will end up on 119. That's it. We just require 2 ranges that I'll write it here. 200.1.1.112 with the subnet mask of 30. Okay, and here it will be 200.1.1.116 with the slash notation of 30. Okay, any doubts guys so far? I
No.
guess this is simplified version of VLSM. Everyone can understand. Clear with this?
Yes.
Okay.
Hello.
Yes.
Yes, I'm wondering about the assigning IP for one. Now that I'm the system manager around, when configuring the system,
Mm-hmm.
my ISP they didn't understand really why they have to. They give us a range of address.
Mm-hmm.
So when we ask two different type of address, it's not in the same range,
Mm-hmm.
and we add a slash 30
Mm-hmm.
in a range and slash 21 or 28 for other range.
Mm-hmm.
So they were really confused. They said that no, we have to do it the same way. We say no, this for I'm working for American government, and in their standard is what they used to do. Why they are not using in the same range?
They're using different or discontiguous ranges.
Yes, different range.
For
But
means
for the
like
one,
a for WAN.
yeah,
Okay, means exactly may I know means exactly what scenario it is. Can you means like a draw for this? Uh, you don't have option for drawing here, but let me.
like
I'll give you a control and I'll give you a paint. Just draw the scenario so I'll get a better clarity on that, and then I can give you so means like a response on that. Okay, so
okay.
so I given you access now. Okay, and let's take one more paint. Okay, Alfred, you can use this paint and just draw a scenario which you want to get clarity on.
We 5 seconds.
You can use this like a router here. Okay, one second. This router. Okay, and suppose this is ISP end router. Okay,
I'm coming. I will take the real draw and be back.
You have a real drawing. So you can copy and paste here on the note, this MS Paint.
Okay, I am back, sir.
Okay.
Hello?
Yep.
Yes, I'm back.
Mm-hmm.
Okay, I have something like this. Yeah, I suppose that.
You want to write something on there?
Yeah, I want to want something here. Yes, that is like the IP address is
If you
like
want
this.
to write, you can use that text box, no?
Okay. Mm. Where can I take a pen to write? Oh yeah, here.
1 second. Here you have
Okay,
pen.
is there?
Yep. You want to write something? See, you can take a text pad instead of that. Just write it here, whatever
Okay.
you want to write.
Okay.
First
I'm
take
going to.
control. Yeah. Now you can write.
Okay.
Mm-hmm.
Like the ISP give
Mm-hmm.
us such address like this.
Mm-hmm. 197 dot.
Like the x.x.
Mm. You can adjust that value. Okay. 25 slash.
30.
Okay.
And in that is for the one.
Mm-hmm.
And for the IP, the range that we use in the system
Mm.
is something like this. Oh, sorry.
1 second, 1 second. Let me take this 1 second.
I try my best. I'll try
Okay.
to.
Okay. And here you want to give some
And
IP
then
address. Yeah.
that's the same.
Mm.
197 dots. Okay, 197 control 197
Let me write it for you. 197 dot x dot
dot x.
x dot x dot
No,
uh
the x again. Hi.
what is the next value there? 26.
The first one is x. The second one is y.
Let it be. We are just assuming these things. No.
Yes, dot.
26.
Yeah. No, not 20. Yes.
Hmm.
No.
Not that
Sorry.
one.
No, is for x for
Hmm.
26, not y by x.
Okay. Hmm.
Yes, that is correct. That to link, that is the one connection.
Hmm.
But behind the one connection, we have this different range of address.
Hmm.
That
Uh,
is dot something.
what exact addresses are there? and what scenario they want to implement this. This is the plain simple scenario, this 197 x.x.25 and 26. So we are having a network of 24 whose usable IP address is 25 and 26, right? And 27 is the broadcast IP address. That's it.
Now the routers, all the routers and the servers have the same address. The not in this range of XX 20 is in another range.
Hmm. So I didn't get
Exactly.
your questions. This see this Alfred, this these values at one point and this value as a other point, it's absolutely okay. What other values you want to see? Means like I'm not getting it. I just write it down. Now means where you want to what values you want exactly there. IP values.
Just put it on the chat window so that we can understand.
Okay, sorry to take your time.
No
And
problem. Just because otherwise the subnetting will be done within next 1 hour. So if it is a worth to discuss, we will discuss it. No problem. We can spend a time on that. It's okay.
okay.
You're not able to write it there. Okay. Okay. Tell me in
What?
the chat. I'll write it on chat.
Okay.
You can also. Okay. Alfred, you are writing in a chat board.
Yes.
Mm-hmm. 1 second. Let me check. Now in my network we use 192.xyz
No, 190.
slash 29 slash 29 you mean to say. Instead of slash 30 now you are using slash 29, right?
Yes.
Okay. So slash 29 if you take, what will be the block size? Let me write it here. This value you mean to say. Control
The
C.
problem is not the slash 29 because we need six eight we need just six address in the network. The problem is the Y inside. The Y meaning that is in this different network, right? A different network address.
So exactly which XYZ we are hypothetically considering. The I mean, so this 192 is a different one as compared to 197. That's what you want to say? Mm-hmm.
Yes.
Okay. Okay. So on the same network you want to implement one. They are asking to implement 192.
No, is in different. They are implementing. We are implementing the network the internal servers
Mm.
are using this slash 39, but it is not in the same address. It is not in the same range of address. Is another network you are using. So the ISP will not understanding what's going on.
Alfred, I'm still not able to figure out exactly where these addresses you want to put up in your internal network or what means like a see
My
if you
internal network.
it's like a this is WAN network, okay, and suppose we have one switch here, okay, and this switch for this switch if we are using this network here, okay, it's your LAN network and this LAN network is connected with the router, okay, this is what we want to implement.
Yes, exactly.
Okay, so this block size of 6 PCs can be accommodated on that. So what's an issue with this? We can accommodate that. We can do that. See, if ISP has given you this addresses, so actually you might have purchased these addresses from the ISP. And
Yes.
suppose we have a servers like this, suppose we have a servers in our domain, we will use these addresses to assign addresses to our servers. So I'm not
Exactly.
considering it as a 192.168. That's a purely private IP address range. Okay, I'm not considering this one. Instead of that, you take any other range, like suppose 0.1.0, okay, slash 29. So we will have a range like this: 192.0.1.1, 192.0.1.2, like this. Okay, like this we can have 192.160, 192.0.1.7 as the last IP address. Okay, so this will be a broadcast IP address. Before that we have 192.0.1.6. Okay, so these are the usable IP addresses that we can assign to the server. And if these are our IP addresses, it it can be published by the ISP to the rest of the world. Okay, and whatever servers we have, if those are published on the internet, that these means internet users can reach to our servers. So how to publish that, that's a different story that we will see afterward, means in a BGP
Okay.
sessions. Okay.
Okay.
Okay, so we can
Yeah.
have a 197 range on the intermediate network where we are connecting with the ISP, and we can have another networks inside our premises that we can use for our servers to be hosted on. Clear with
Okay.
this?
Clear.
Okay.
Thank you very much.
Okay, I hope this is clear for other guys also. If not, we will have a session on BGP that time. Same similar kind of scenario we will take, and we will do a practical on that. So we'll get a more clarity on that then. Guys, next we have the CIDR, classless interdomain routing, and we this time we will do little complicated examples as compared to the previous one. So far we have taken only class C range into consideration. So this class C range is pretty simple to do a calculation on, but we have to do few calculation from class A point of view and class B point of view. So it will become little complicated, but if you follow the same pattern, eh, it will not be a very difficult, or it will not be a impossible thing. We can work it out. Okay. So classless interdomain routing, where this boundaries of class full, like class A, class B, will get diluted, and we can have ranges like /9, /10, /11, like this. So if you take /8, it will be 255 0.0.0. If you take /9, it will be 255.128.0.0. Why I'm taking 128 here? Because 1, then all zeros, so the value will be 128. If you take /10, then first 8 bits will be 1, that is 255, and next 2 bits are there, means 128 plus 64. If you add them up, it will be 192. Likewise, you just cross check all these values and don't stop here. I'm i'm asking you to do a complete calculation up to /30. Okay, that will really help you to understand this subnetting very fast. If you get uh, like a practice on these things, your calculation will be very fast. See, when you going to give exam, that time we have very limited time to answer all these things, and in interview also, in a in real scenario also, if you keeps on doing calculation on paper, it will consume more time. Within a 30 second you can, or less than that, you can come up with the answer if you know which slash notation represent which decimal values. Okay, now we'll take class, where we are, class B scenario for the network. Okay, 150.5.0.0, and we need 100 networks for this. Okay, so 100 networks means what? How many bits will be required for 100 networks? For 100 networks, we cannot give the first stack. That first stack is 128, right? So we have to do a calculation from the 64. First subtraction will go on 64. So some of the bits will be turned on and some of the bits will be turned off. But 7 bits will be required. 1, 2, 3, 4, 5, 6, 7. Okay, so that's why here I'm writing it as a 7 bits. Okay, or I written it as a 7 bits. Okay, then we have to adjust this 7 bits in the subnet mask. Now we are not doing class C, we are doing class B. So class B means 16 host bits and 16 network bits. First 16 network bits and then 16 host bits. All 16 1 is network bits and all 16 0 is your host bit. Okay, because your subnet mask is 255.255.0.0. Okay, and if you convert it into binary, that will be 16 1 and 16 0. Okay, and what we want here, we want additional 100 network. So for that reason we are adding 671 additional 7 1 bits. Okay, and then rest of the bits are 0 bits. So your slash notation is slash 23 now instead of slash 16, because additional 7 bits we have added as a network bits. Okay, and your increment or block size, not block size, we can say increment size is 2 now, because the weightage of this 0 is 1 and the weightage of this one is 2. Okay, so that I'm writing it as the increment size of 2, and the subnet mask in a decimal format is 2255.254.0. Okay, so that we can arrange in the ranges like 150.5.0.0, 2.0, 4.0. Why we are doing this increment in third octet? Because we encountered this, we have seen this in the third octet only, this increment bit. Okay, so we will use this in the third octet only. Okay. Any doubt in this? I guess this is also very simple to understand if you follow this pattern. And from this ranges 0, before 0 we have 255 and before 2 we have 1. Guys, one question, what is a block size in this case? How many hosts we can accommodate in these ranges? Guys, you understood my question. My question is how many hosts we can accommodate in this calculation or in this subnets? Sujesh, you understood my question. My question is, what is a block size? Increment size is 2, but block size is not 2. Block size is more than that. How many host bits we have? This 7, 8 host bits plus this additional 0. So it's total 9 host bits we have here, right? If we have only 8 0 bits, then the block size is 256. And if you increment one more bit, that will double the value. Means here we have 256 and this additional 0 means double this value. Means 256 double is 512. So the block size should be 512. Correct. Alfred responded. So I hope this is clear for you. 512 is the block size in this case. Okay. Next, we will do a calculation for class A, and we want 1000 network out of this class A. Okay. So for 1000 network, we have to little stretch our calculation of this 128. Okay. So we have 512 and we have 256. Okay. And before this, we have 1024. Okay. How many networks we want? 1000. So if customer require 1000, we cannot give 1024. We can give 512 only, 512. So the first subtraction will go through this 512. Okay.
10 bit.
So total 10 bits are required. This 8 bits plus additional 2 bits. So total 10 bits will be required. So that's what I written in the document also. Find bits required for the networks, that is 10 bits. And if you go with the class A subnet mask, 8 times 1 and 24 times 0, that we have to adjust with additional 10 network bits. So additional 10 networks bits that I have adjusted here. This additional 10 network bits. This, okay, let me write it here. These are the additional 10 network bits. Okay. And the increment size will be 64 because the weightage of this one is 64. And if you take a decimal value subnet mask, it will be 192 and it is /18. Okay. And if you do a calculation on range, it will go like this: 10.0.0.0, 10.0.64.0, because the increment is on third octet. Furthermore, uh, we have to keep it incrementing in third octet here: 64, 128, 192. Okay, like this. Okay. If you add additional 64 on 192, what will be the value? 256. Is the 256 possible in our calculation? No, it is not possible actually. We have to take a zero value here and we have to give a carry forward to the next octet. So we'll take 10.1.0.0. So the next range will be 10.1.64.0. Next range will be 10.1.128.0. Next range will be 10.1.192.0, and the next range will be 10.2.0.0, and this pattern will keeps on repeating because this is the binary nature of this calculation. Okay. Before 0 we have 255 and before 64 we have 63. Like this we can do the calculation for this class A network calculations or the network scenario calculation. I hope this point is also clear for all of you. These are few practice examples that you can solve. Okay. Rest of
So
the
in this
question,
scenario, what is
this last one.
yeah, in this scenario, what would be the block site? Like there would be
Mhm.
14-0
Mhm. See, this will go like this.
to 56.
1 second, let me write it. Up to this, what is the block size? 256.
256.
Okay. On every incremental bits, it's going to be doubled. So here we have
512.
512. Okay. Here we have
1024.
1024.
24.
Okay. Here we have
20.
2048. And here we have 4096.
90.
4096.
96.
Okay, 5 and 2, 1024. This is 2048. This is 4096.
It
Okay,
means double
mm.
every time,
Every
right?
bits will keeps on doubling this value. Here we will have 8166 means 2, then 9 18 18.
Right, got it.
Okay, 8192, I guess this is 8192. Okay,
Yeah, yeah, got it.
so like this we will have the values, and this actual calculation is on 2 raised to n, but not required to do this at this stage. This next value will be something on 16,000. Okay, next value,
Mhm.
so the block size will
Right.
be 16,000. Okay,
So can we do like 2 to the power 14?
yeah, we can write like this also.
Oh,
So 8 bits here and 6 bits here. So 8 2 to the power 14 minus 2 will be exact usable host IP addresses.
right.
Okay, let's clear this. Next, we have the calculation for few practice questions that you can do at your own. Okay, and host based calculation we'll do in the tomorrow's session. Okay, and few reverse engineering calculations are there that also we will do in a tomorrow's session. Okay, we'll stop here. Rest of the points we'll cover up in tomorrow's session.